So, this is session number 2 of our fusion modeling session. So, we're going to pick up where we left off last time with this little hinge joint right here with the servo, and I've already put this like in place like that, right? And what we want to do here is I've made up a quick sketch of a mechanism that I've been thinking of, just like this. So we're going to be modeling that, and hopefully all of the phalangeal joints. So yeah, this is going to be quite a while, but I'm up for it. Literally, I'm up for it. So so what I really want to do now is this latest edit that I did, which this latest extrusion, I'm not really fond of it, so I'm gonna get rid of it. Not this one. This one right here, where I extruded this, I'm gonna get rid of this. I'm gonna get rid of this as well. So this will be the proximal phalangeal joint. This is kind of just the palm section. This is like the metacarpal, I guess. So usually you kind of want the proximal phalange to be pretty long, and we want this to protrude a little bit upright. You want this to have a little like a curve, I guess. So we're kind of just gonna have to FreeCAD this, really. Just whatever works, I guess. So let's try to honestly, I think I'll keep it level for now. So I'm gonna keep this level just for now, I guess. I should probably be moving it a little bit, so this way, right? So now that have it this way, I want let's see, let's take the diameter of this tubing here, 4 millimeters. So 4 millimeter little thing. So what I'll actually do is I'll construct the line like this, and then I want to move this, actually. That's not what I want to do. I should be doing this. I'm going to do this. I'm going to put it at a 45-degree angle, and I'm going to construct one right here. And now I'm going to move this back. Crap. I just realized that I can't really do that. So I'm actually not going to do that. What I want to do is I want to create a body. Yes, that's what I'll do. I'll create a body like this, right? 0.42. It's just got to be 4.2. 4.2 millimeters. Because you want to think about the printer tolerance as well, right? I don't really know if 4.2 is going to make much of a difference, but usually when I print, usually when I make these kinds of models, I just do it all the way, but maybe it's different. So I'll just try it as an experiment. So now I have this 4 millimeter tube, and since I have a 4 millimeter tube, what I'll do is I'll just put it like this. Make sure it's in the middle. It seems to be in the middle. And I'll go at it from here. I'm gonna rotate it 45 degrees. And then I'll just move it like this. Bam. That seems pretty good. And then I'm gonna do I'll do this. I'll just through like that. Now we have a 45-degree angle hole in our CAD. So that's pretty good. Now how about we try splitting this in half? Let's do a construction line, 8 millimeters. And we're gonna split this body. So when we split it, we can see that it's good. And now we want to have a thing at the front. That's in the middle, so it's good. How about a 4.2 right here? Let's do that. And then we want to just cut it into there. Let's just try to smooth this. Let's do it halfway. See if that's good. Oh my god. Okay, maybe that was not good. Maybe just on the spot is good. That's kind of rough. I don't know if I like that. Let's try to get it up to, let's just do 10, right? -10. -10 cuts it all the way into it. Let's do 9. -9 and it makes this weird divot. I don't like that. So let's try moving this and then we'll try it. And so we can actually see a good side view. I see. So it's the magic spot really seems to be 8.6. And that makes it a nice spot like that without any weird divots or any things like that. So 8.6 is the magic number. -8.6. There you go. And let's just try one on the other side. So we're gonna have to move this up actually. I'm gonna just hide this face. There you go. Okay, so we want it to be like here. Nope. Talk about 1 cube higher. There you go. And then we're just gonna move this to see what's here. Yeah, so 8.6 seems to be the same on the other side as well. So we're going to do -8.6. -8.6. Bam. Now let's see. It's good. That's great. That's great. Okay. And then we're going to do... let's do this. Do a let's just measure this actually. So this is 0.635. So I'm gonna do that. .635. And then we'll just join it. Bam. And on the other side, let me just check it here. Hold on. Yeah, let's just try that. So this is 1.165. One six five. Bam. Then just join it. And then let's just do a construction. I think it was like 6 or 8. Yeah. And we're gonna do a split. See the cross section? That honestly doesn't look too bad. I can see the tubes going through there. Maybe that's actually pretty good. I bet when it's printed and we heat it up, it's gonna be pretty malleable, so we can just slot them in. Yep, we're cool. We're cool. So we actually want to keep them split, just like that. And then what we want to do is we want it to be kind of like modular. So let's just try, if we try and do something along those lines, if we can. So what is the height of this? From here to here. And are these not level? Okay, so do this, and then we're gonna move this so this stays a single object. And we'll just do, I don't know, 2 millimeters is good. There you go. And then that kind of just slots in like that. I don't know if we should have anything else. Maybe we should have some sort of connection piece right there. So I think it's fine if the top just slides in like that. So you want to have a smooth top, but right here you want to have a maybe some sort of connector. So let's just try doing that. Three by 6. But you want this to be a little higher. Let's try 3 by 6. Bam, right? And then just try cutting down in here. Carve it in 6. Or 3. How about -6 or -6 is good. So and then we take the measurement from here to here, which is 6. Here to here, which is 3. Okay. Then we just make one right here. Honestly, I think it's good if I just do this. And then I move this out. And then this goes up, how many? From here to here is 6. So This should go out 6. Then we move this move. That fits in pretty well. I think it's good. So it just fits in like a puzzle piece, right? I know we should probably be doing that on the other side. So since that's the protrusion there, the protrusion side on this one should be right here, I think. Yeah. Three by 6. That's good. So 3 by 6, just like that. And then with the 3 by 6, it should be -6, which I don't think should be interfering with the tubing section. And then one right here, so just do this. Here to here. I'm gonna move this. And this is gonna go up 6. And move it back. There you go. It's fun to stay at the YMCA. It's fun to stay at the YMCA. It's fun to stay at the YMCA. Wow, this is awesome. Okay, now let's try to. This honestly looks like a pretty good phalangeal joint to me. With the tubing, that should be going from under. So if you think about it in that perspective, in which it should be like here. Oof. Yeah, that is low. Oh my god. We can honestly just. It seems like it'd be kind of giant. I don't know how we're gonna deal with that. I'm not sure. If we just think about, okay, let me get a reference point here. Yeah, sure. So with the V2, right? It was right here, in which the tubing will go through here. But for V3, you want it to be going from under. It goes up top. It's the current way that I have it set up. It would have to. It would really have to just be the two would have to come out and just be like a flexible piece, in which it would have to rest against one of these. So it's not really. I don't really know if I like the concept of that. That just seems kind of, I don't know how to explain it. It just seems kind of weird, because it doesn't really make much sense as to why it would do that, right? So I don't don't know. That is strange. Very strange. What is the next from here to here is 2? Okay. This one's a stay at that. Just get 2 on down. Alright, so this is like a big weird piece that's just chunky. I don't particularly like how that looks. I'm thinking if you were to have it or go from here and come out that way, where it would really just be connected to the phalangeal joints. So how would I want it to be out the back? Which I'm not exactly sure how I'm gonna achieve that. I think it'll be fine if I just use something akin to the old mechanism, but that one had a lot of friction, and I'm not sure I like the concept of having so much friction. Another thing I could think of is we could use the just springs as a way for these to pass through, right? It could honestly work, because you know, extension springs, when they're inwards, it's pretty easy for it to bend and act as like a nice what do you say, a nice passageway for the string to go through. So I could honestly see that working. Now this thing's like giant. I don't know how or why it's like that. I don't. Jesus Christ. I'm gonna kind of smooth this out, because Lord, good Lord. Okay, so the maximum smoothness this part can have is 2. This can have a smoothness of 7. What is the smoothness of 7 here? I see. It's not symmetrical just because of this piece. I don't really know if this was a good design element. Yeah, I don't know about that. I think it'd be good if I just make it a solid piece, right? For what it is, for now, it doesn't have to have that. So I think I'll just keep it like this. Just for now. Since this is only like a prototype, it doesn't really matter if it's like fat or nothing or what. That's fine. Okay, I'm just gonna have it like that. We'll figure it out later, I guess. I'll just put like 2 plates right here. Or I'll just like solder it in place or something. I don't know. Just for now, I guess. And then we just want to make sure the 2 passes through fully. And it goes out right there. Yep. It's pretty good. And then, I mean, this thing's about the size of a servo, so it's not terribly large. However, when you compare it to a real human hand, it's pretty large. So if we think about bending motion of this. This would be like that, which it's actually not horrible. So it's just, I don't know, freak add some stuff here. I'll add like a weird bracket piece thing that's like super long. So this actually acts as the first metacarpal. Not the metacarpal, the first phalange. So, yep. Why is this here? I don't know. You tell me, why is it here? So now, this is just the prototype phalange, right? But actually, I don't want that. I don't know why I made that. What I actually want is I want some good small ball bearings. So, something that the Robot Studio uses. I really like the way the Robot Studio uses his ball bearings. He is, I think, one of my biggest inspirations in the way that he uses his components. So, a finger overview. What ball bearings are these? What is that? What? Whoa, these are the ball bearings I'm guessing. These small precision ball bearings, 11. How much is in here? 10 packs? I don't know how small these are. What's the sizing on? Oh, right here. This is a, how many inches? So this is 0.24. So I guess that's the inner diameter, which is actually gonna be 0.39. That's the outer. That's actually very small. Huh. And what's the other one? 6. This is for the wrist. This is for the hand. Now for the sample finger. What are these? Wow, these are tiny. Looks like this is the one he's using, so this one looks pretty good. For 10, okay.
There is 105%. And as for split.
Wow, just look at the modeling on that. Each piece and each groove and each indent has its purpose. There's a reason why it's there, you know? Wow, it's incredible. Okay.